everyone, so for this week we're going to be learning about functions once again. We're going to be looking at the domain, range, and minimum and maximums. This is a review of what we did last week and the week prior for the CFA when we're looking at domain and range and writing an interval notation. So for domain and range, we're looking at the smallest value and then the biggest value, and you're rewriting those in this format right here where it's a low, comma the high. And then what we're going to be doing is looking at brackets and parentheses. So for the brackets, our exact values are closed dots, closed points. Parentheses are for non-exact values, open points, or infinity. Okay, so when we're looking at all the possible values of x, what we have to look at first is we have to look at the domain. So the domain are all of our x values, our x coordinates. So we're looking at this line right here. If we're thinking about the graph, and we know that this graph, let's change the color back to blue, we know that this graph extends all the way on the ends that they're describing, then you can imagine that if it goes on forever and ever and ever, even if we follow down this purple line, this x-axis, we will still be able to find a dot on the graph, somewhere up here in this area, somewhere up here in this quadrant. And for this graph, if I follow this purple line, I can follow and point out a dot on the graph, or if I follow here, it's going to be a dot somewhere down here. So I know that I will always be able to find a line on this domain no matter what on either end. So each graph has arrows that extend from both left and right. They go from negative infinity to positive infinity. So I can go on forever to the left, forever to the right. There will always be a dot written down. So how we write this is negative infinity to positive infinity. That's the interval where all of our possible x values exist. Another way to write that down is all real numbers. And this is showing you what the double backed R is, but it actually looks like this. So there's more than one way that you can use this, but this is not to, confuse you with the fancy R. This is all real numbers. Alrighty, so now the different thing that we're going to be looking at is the range. So the range this time is going to be looking at the x-axis or the y-axis. So looking at all the y's, looking at all of these y's right here, we have to look at the lowest and then the highest number on the x or on the y. So in this case, if we're looking at this graph right here, if we're following down this y-axis, you can see that this line is the lowest that it can go. However, if I go all the way up, it will continue to extend. For the graph on the right here, the highest number that we see is right there at that 8, and then it keeps going forever to the bottom. So notice how I draw my arrows to show the direction of where all the possible y values go. You can see that the arrows extend up or down. So in this case, here is my low, here is my high, here is my low, and there is my high. I write down my values, and you can see that my low number is written, my high number is written, my low, my high, and then this is the interval that I correct. So my lowest value is at a -6. You can see my lowest. It is a closed dot or an exact dot, so it has a bracket. Now, the highest goes all the way up to positive infinity. Since infinity is not an actual number, it's an idea, it has to have the parenthesis. Same with this, my lowest is infinity, my highest is 8. So my lowest comes with a parenthesis, my highest comes with a bracket. Now, this is the question of which one do we have minimums or maximums. So on the left side, is it a minimum or a maximum? And then on the right side, is it a minimum or a maximum? So what's the left? And then what's the right? All right, so the right side is minimum. Sorry, the left side is minimum. Now we have to think about what's the right side. The right side is maximum. Okay, so now what we're looking at right here are the minimums or the bottoms of different values and different points. So you can see right here that there is a minimum of -4. Here there are 2 minimums, one's at -4, and one's at -1. Here, for graph number 3, there are three minimums. Sorry, not three minimums, one minimum at -3. And you can see with this 4, since this graph goes on forever on either end, there will never be a minimum because this actually goes towards negative infinity for my y value versus this goes to positive infinity. So because it's not an actual value right here and it's an idea, there is no minimum for this. All right, so now what we're going to do is looking at the maximums. Same thing, but this is the top of the peaks. So right here we have a maximum at 8. Right here you can see that there are two maximums, one at 5 and one at 6. Here there's one maximum that's right at 8. The drawing's not exactly lined up. And here once again there are no maximums. So notice how in this graph number 2, this graph will go on forever to the top. Same like this graph right here, it will continue to go forever up and up. But relative maximums are the top of any hill. So although, there can be like a positive 10, a positive 12, a positive 20 as a y value, these are maximums in their area, okay? This is also maximum in their area. So whenever there's a change of slope, all right, so now what we're looking at domain and range. So looking at this graph number 1, we have to look at the lowest value of x and then the highest value of x. So for my domain and my x, that's not my x, wait a minute. For my domain of my x values, that is when I have to look at my x-axis. So here's my x-axis, and you can see because of these arrows, it continues to go in both directions. So you want to think about having this as all real numbers, and this can go all the way to negative infinity. My x-axis can go all the way to positive infinity. So negative infinity and positive infinity. Now, if we're looking at our y values are going to be a little bit different. The lowest y value that we have is right here at 1. And my highest, because of these arrows again, it's always going to go up, up, up. So my highest is actually going to be all real numbers. And now the question that I'll ask you, see here, is based off the image, do we have a minimum or do we have a maximum? Minimum or a maximum? All right, we have a minimum. So here is where we input in all the information, and now you can see that it is included in the bottom piece. Now we're going to move on to graph number 2. So graph number 2, we're starting with our domain. Once again, that's our x-axis, our domain. So because this is going all the way up, not only do these arrows signify they're going up forever, they're also going left and right forever as well. So this is another case of where the domain is a negative infinity, and then the domain is a negative infinity to a positive infinity, or you can write all real numbers. Now for the range, we're going to use a different color for that. Our range, let's do green. So for the range, we're looking at our y range. So if we're looking at our y-axis, what is the lowest y-axis that we can have? This line right here, which is a -9. And then what's our highest? These arrows, once again, go all the way up top. So my highest is going to be a positive infinity. And now we have to think about this line. Is that a minimum or a maximum? It is a minimum. Okay. So you can see here how that's included now. Oh, wait a minute. There's an error here. Excuse me. So let me go and correct this error. Silliness, Chia. All right. So the domain we said were all of our x values. So this is a negative infinity and a positive infinity, negative infinity, and positive infinity, parentheses. And then for our range, we have a low of -9 to positive infinity. But since -9 is an actual value, it's going to have a bracket, -9, positive infinity. Alrighty. And now we're moving on to the very last one. So the very last one, here. Alright, so the very last one is where we're looking at our x values. So our x values this time will look a little bit different. Let's use a purple. So for our x values, we have to look at our x-axis. What is the lowest x-axis or the x value that we have? Right there. What's the highest x value that we have? Right here. So here I have a -3, and then here I have a 2. And now we have to look at our highest and our lowest y values. So if our y values are right here, the lowest y value that we have is at -5, and the highest y value that we have is at a +4. So let's do -5 and a +4. And now what we're going to do is we're looking at the minimum and the maximums. This right here, what is it? It's a maximum. So now what we're going to do is we're going to move on to the next slide. Okay. So I'm going to erase this. And what you can see now is that we have the domain as -3, +2, and then our range, and this is in purple, and then our range is a -5, 4, and that is in the orange. And it has both a minimum right here, and it has a maximum right there. Now, one important thing that we see are the differences in how we write our intervals in our dots. So in this location, it is a closed circle. So that means it includes and is exact, which is why -3, 5, or at this point, they have brackets. But if you look at this next point right here, this next point is a 2. So this 2 signifies an open circle, so that's why this has a parenthesis. All right, so now we're looking at this one right here. We're going to move on, and then we're looking at the domain. So I'm just going to indicate where the domain kind of lays with our lines. So for right here, I'm just going to look at the x-axis, and I'm going to notice that these have arrows. So these are going to continue going on either end. So because they're on either end, I'm going to just shortcut it, and I know that they're already going to be all real numbers. Now I can look at the range, and I'm looking at my y-axis, and I see that the lowest value of my y-axis is right here at this, but then my y-axis will continue to go up. So I already know my lowest number and my highest number. Lowest would be -6, and my highest would be infinity. So how would I write that range? And then last but not least is my minimum and maximum. So let's go ahead and show the answers. So here I have that domain is all real numbers, and that range is -6 going all the way up to positive infinity. And which one is it? Minimum or maximum? It is a minimum. All right, moving on to graph number 5. We have to think about what is going to be our domain and what is going to be our range. So our lowest x value is right here. Our highest x value is right there. So what do you think our domain is going to be? Hopefully you said -4, +3, which both have brackets because they all have closed circles and exact dots. Now what we're going to do is we're going to be looking at the range, and we're seeing that the range has a lowest value of -5 and a highest value of +5. So here's a -5, here's a +5. They both have closed brackets. And notice that there are actually minimums and maximums. This is a relative or this is a minimum and this is a maximum, so it does have both. Alrighty, last but not least, we're looking at domain and range for this very last piece. So this, what you should notice is it is a straight line, and a straight line means it goes forever in a direction on both ends. So not only is it going forever left and right, but it's also going forever top and bottom. So if it goes in both directions for the domain, you can write all real numbers. For the range, you can write all real numbers. You can also write all real numbers. You can also write down negative infinity, positive infinity, and making sure that you have parentheses because, like, once again, infinity is not an actual number, it's an idea. When I have a straight line that goes forever and ever and ever, there is no minimum number and there is no maximum number. So it is none. Alrighty. Last but not least are translations. So if I had a graph, this blue graph right here, I can adjust my equation a little bit by changing up my numbers and adding to the equation, and then it just moves my graph around. It does not change its shape, but it does move things around. So if we're looking at this x squared, if I did plus 2 in my equation, I shifted my graph 2 spots over relative to my x. If I do minus 2, I shift the graph 2 units over in relative to my x. Right here, you can see that I'm adding or subtracting 2 in relative to my x, so I move it over. But then I also have this plus 2, which directly affects the output or the y value. So that's why it has a vertical shift, which is this 2, and a horizontal shift, which is this 2. Now, with this shift that we see here, you see that I start with the red and then I flip it over to my green, and all that I changed was this negative in front. So by adding a negative, it was able to reflect my graph over the y-axis. So the blue line is a parent function, so we're starting with the blue, and the thing that we're changing, if you're just looking at it, it goes down 2. The same shape goes down 2, and if you look at the equation difference, I start with x squared, and then I move down to x squared minus 2. So although it looks wider, all I want you to think about is if you drag the blue graph down 2 units. Alrighty, so here, this is simply just looking at the domain and then the range and the y-intercept. This is a preview of what we'll be doing in class. If you watch the end of this video, I will not be asking questions based off of it, but some observations that you can notice is that this is a straight line and this is a straight line. So this is a straight line. So for each of these, the domain, because they're all going forever left and right, the domain is going to be all real numbers. So the domain are going to be all the same. The differences between the range is that the range is changing in the y values. So this goes up and down. This graph obviously goes up and down. But this graph right here stays at the same y value. So for this range, the range is only 2 because it stays. So for these two, I'm going to go ahead and then write it down. The domain is all real numbers, all real numbers. And then this one's also all real numbers. Now my range is also going to be all real numbers for this, all real numbers for this one. That was really bad R. And for this, for my range, it's only y is equal to negative 2. Alrighty, and that is the end.